Alright, hello, we're live, we're back. This is video number 2. We will start coding. The outline of this video is, first I'll try to use Google Sheets, particularly Sparklines, in order to introduce you to some visualization that requires some coding. There are, as you know, we already have buttons to generate charts and then you can just use them. However, we're going for more expression and we can express problems and solve them more if we do some coding. So this is what I'll use to introduce you to charts that would require some code to create. Hopefully that would make us understand how to use Jupyter Notebook in order to code our way towards a visualization. So hopefully we arrive at something like this. And then after that, I am hoping that would be enough introduction for you to understand a file that I would let you study. The file contains numerous amounts of the crazy things you can do to visualize data. And I would leave you with a few questions so that you can practice your data visualization thinking. All right, so let us start. This is a Sparkline. Let's try to delete everything. And a Sparkline is essentially Google's way of representing bar charts, line graphs, and graphs of similar graphs. So how do you do it? Suppose we have here student A, and let us pretend these are quiz grades. You have a 95, 70, 90. Let's not put negative numbers yet. Let's have 88, and let's have maybe a 60. All right, how do you generate a graph inside one cell? Google allows us to use what is called a Sparkline. So in order to activate that, you just treat it like it's a formula. So equals Sparkline, and then it tries to ask you for two things. One is the data range, which means what part of the spreadsheet do I want to visualize, and so we can just drag it here because we want to visualize the grades. And the other component, the other part, which I can invoke by pressing the comma, there it tells us it's now ready to receive options, would be attributes that we can edit depending on how we would want the graph to look. Let's first take a look at generating the Sparkline without any options, without any attributes. If I hit the enter key, I get this pretty neat looking graph. It tells me that the grade at the start was a little bit high, then it went down, then it went high again, a little bit down, and then way down. That's good information. It's simple, it's precise, it gives me an idea of what happened with the grades. If I would want to make this a little bit fancier, the documentation of Google gives me this. Sparkline, I can use it this way, and I have the following syntax to work with. We already know how to plug in the data, and that's just highlighting the boxes that we need. Options are the following, all of these things. So let's try to explore what they do. Say for instance, we would want a bar graph instead of a line graph. Then we just say that the chart type should be equal to a bar graph instead of a line graph. Let's try to do that. So that's our data, comma, so we enter the attributes, and all attributes should be invoked by enclosing them in curly braces. Here, and an example is neatly prepared for us. Look at that. Let's just copy that. So chart type, we say that our chart type, comma, we want it to be, let's try columns so that we have columns for each grade, right? Column first, column. There you go. I hit the enter key. It tries to render it for us. Then I have this neat looking column graph. It's a variation of the Sparkline graph. So let's try to analyze this one. Notice that 95, because it's the highest number, is automatically selected to be the maximum value or the maximum vertical length of one bar. Sometimes that helps, sometimes it doesn't. Look at 60. It's the least amount of it's the least grade value that we have, so it's automatically at the floor of the space where the graph is generated. Suppose we want our limits to be 100 at the top and then 0 at the bottom, so that if the student gets 60, it's not really at the floor of the space where the graph is generated. We can just add attributes. And the attributes that, or the sample attribute that we can add is here for line graphs, for column. All right. For column graphs, we say that the y minimum, the y-axis minimum, would set the floor for us. Y max would set the ceiling. So, in order for our graph to be a little bit more accurate than this one, that assumes that 60 is the least, is 0, let's add a semicolon and then add a y max, which, as we have agreed upon, is 100. And then let's also add a y minimum that we said should be 0. If we try to hit the enter key, we have this graph that looks like a little bit more accurate that towards what we want. We don't want 60 to be the 0th. We don't want 60 to be the floor. So 60 is somewhere around, if we try to edit this and make it 50, we see that the graph is, the bar is midway between 0 and 100, which is accurate for our purposes. So notice that what we did was to add attributes. You control the nature of the graph by adding attributes. What more can we do? Well, we can maybe add a color to the bars. So if we say, I want to add a color to the bars, I would want to make them red. Voila, the bars are red. And also, for those of you who took up web development class, you can also use your hexadecimal colors, which is neat. If you try hashtag RGB and maybe replace R with 9 and B with 9, also set the G component, light component of green, to 0. We have red plus blue, which should give us a beautiful violet color. Cool. Now, as we have discussed in the first video, we want to say we are trying to highlight, suppose we want to highlight the maximum grade. How are we going to do it? Well, we can just add, based from the documentation, it says that the high color sets the color for the highest value in the chart. So if I try to edit this again and say that the high color would be equal to yellow, all right, we anticipate an error. Let's just delete this, sorry. Make sure your parentheses are complete. Parentheses, that's braces, parentheses. Okay. Notice that it did not highlight 95 to be yellow because we have set a ceiling, the Y max. So whenever you set a ceiling, the only time that it will highlight the top color if it's equivalent to the ceiling. So if I have 100 here, then you get 100 there. If you take away the Y max though, and then do this again, and then even if this is not equal to 100, but it is the highest color, then notice that it gets highlighted. If I try to do a 104 here, that one gets highlighted, and then the bar just readjusts itself accordingly. All right, what else can we do? We can have support for negative numbers. So say for example, I would want to neg color negative color. Negative color to be, what's a good negative color? Maybe red. There. And then let's change this to -5. Alright. It doesn't show anything because again, we have invoked that the minimum of the y would be 0, which means that if I have a negative value there, it wouldn't be represented. And so this is your call as a designer. Do I want to set limits or not? Maybe I do, maybe I don't. If I say that I don't want limits, then I can just delete this and then see that it gets represented in the graph. It looks a little bit incomplete without a line, so let's try to add an axis and set it to true. This is just telling the graph to have an axis, the line that divides the positive numbers from the negative numbers. If I have that, then I have this cute little line that just gives me an idea of where 0 is. Okay. If I have a couple of more students, student B, student C, and they all have their grades 88, 88, 90, 104, brilliant, 60, 77, 100, and maybe some more dummy numbers here, 77, 789, 98, 87, 88, a line left because I'm OC like that, I mean a line right, okay. I could just copy this one and see for myself the strength of my students. Alright? So, case in point, graphs can be, and there are several others we cannot cover, but we'll leave them to you to explore using the exercise that we will give you at the end of this video. There are a lot of ways to do this. This is just one, but the main point is there are graphs that you can utilize, and the graphs that you can utilize can be edited, tweaked to your purpose using attributes that you can turn on and off or edit in value. Now that that's done, I would want to introduce you to something called Jupyter Notebook, which is the reference being used by the other sections. So to keep everything uniform, we will also try to teach you this. I'm not really sure if the other sections have CS background. You told me you don't have CS background, so I tried to rewrite the activity, the initial exercise, so that it hopefully gives you a little bit of scaffold before diving into coding. This is the Anaconda Navigator, but the Anaconda Navigator is not what we will use. We are particularly interested with this, the Jupyter Notebook, because the Jupyter Notebook is what allows us to do all the data visualization stuff. So in order to download this, you go to Anaconda, here. If you search Google for Anaconda Navigator download, you just click on the first link that appears. It should take you to a page that looks like, wait, scroll up, this. If you scroll down a little bit, you will see Anaconda 2020.02 for Windows, Mac, or Linux, depending on what OS you're using. Kindly download Python 3.7 version. That is what we will use for the exercises. If you download that, you will be able to run it and see something like this. If you click on Jupyter Notebook, it will open something like this. Well, let's try to open something new. File, new notebook, Python 3. This is what you will see. Alright, that's your Jupyter Notebook. Now, how do you use it? Okay, here. This one. This is the sample dataset that we will try to make you explore. It's provided by your Sir Gabo. And I don't understand cars, but I'm using context clues. These are cars, and these are attributes that you will often see in cars. Okay, how do you? All your Excel files are essentially comma-separated files, vice versa. So how do you take this CSV file and put it inside your Jupyter Notebook once you have already installed it? Well, the thing that you need to do first is make sure that this file is called emptycars.csv, and it is in the same folder as my Jupyter Notebook installation. So if I create my Jupyter Notebook installation, create it in a folder where the emptycars.csv is also located. Alright, what do we do first? This is called a cell. You type commands in the cell and then hit shift plus enter. It tries to run the command. If your command is erroneous, you see something like this. It means the computer cannot understand what you're trying to let it do. And you can edit it. Of course, when you get errors, you can always edit it. The first command that we will want to do is to import the library that allows us to process CSV files and process Excel files. Here's what for those of you who don't know yet, in coding there is something called a comment. When you write a comment and you run it, the computer doesn't execute. This is the part of the code that you can use to explain to yourself what you have just written. And so you may say things like, this part of the code will import pandas. Pandas is the library that allows me to do visualization. Okay, so any line of code that you write after this hashtag symbol is a comment. If you shift enter, the computer will not run it, but it gives you the benefit of understanding what you're coding. So in order to import pandas, this now computer code, you want to import pandas as PD. What does this do? Alright, I just hit shift enter. What does this do? It means that I can already use all things in the pandas library through a nickname that I gave it, PD. Okay. And then the next thing that we will need to do, let me try to just review so that I don't waste your time more. Alright, here, we want to read the CSV now. If we want to read the CSV, you know what? Let me just copy paste this and then explain to you what it does. This is my file. My file is a container upon which you will try to pass whatever is inside emptycars.csv, and you do it through a command called readcsv that is part of the panda library. And so you're referencing pandas using your PD variable. If I try to shift enter this one, don't worry, I will try to give you a copy of this small code snippet too. Nothing happened, but when you're coding, nothing happening is actually okay. When something happens, it means you have an error. And then when you run something and nothing gets returned, then you're good. At this point, my file already contains whatever is inside my CSV, such that if I invoke my file, I hit shift enter. This is now the contents of our CSV file, as you have seen a while ago. So I have the names of the cars, the MPG of the cars, the SIL of the cars, cylinder. I'm not sure really. I don't know cars, but those are car attributes. What can you do now with this one? Well, código dito ka. All right. What can you do with this one? You can access records. Say for example, you want to see what's the first car in record. Well, because we have already placed everything in my file, we can reference my file now. How? We can do a myfile dot location 0. Location 0 is essentially this one. It's indexed 0 to any number that it's referenced 0 up until your last possible record. So if you have 100 records, in order to get each row, you begin from 0. So first record is actually index 0. 100th record is essentially index 99. So if this is index 0, I hit shift enter again. I get the Mazda RX4, which is the first one in my record. Neat. Alright, what else can you do? Look at this. My file dot, and then I give it a name of the column. Let's choose MPG. My file dot MPG. Enter. Convenient. Look, it gives me all of these values in order. Sorry, I'm trying to say it gives me all the values under the MPG column in order. 21, 21, 22.8, 21, 21, 22.8, up until 21.4, that's 21.4. So in order for you to get the rows, or we have a mechanism for getting the rows. We also have a mechanism for getting the column. So that means we can conveniently now create some kind of sparkline or bar graph or any other more complicated graph because we have access to these things. Sige, let me try to proceed. Halimbawa lang. Say for example, I want to display only the MPG of those people of the cars whose MPG is greater than greater than 15. Yun, greater than 15. I want to display, so here, I want to display the cars whose MPG are greater than 15. I would do it this way, and I have a couple of steps. First, I would want to say my file dot mpg. Let's just do that again. But now this time greater than 15.0. Look at this. It returns to us Boolean values. Boolean values are true and false. And some of the records return false, 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 false. What does that mean? If we try to put this as this whole thing that we created, our true and false values, if we try to put that as a condition to a new list that we will create, hit the enter key. Notice that, let's check. We should be able to notice that MPG, here, all the MPG values that I see are those that are greater than 15. We missed this one. Record 14, record 15, they are not here. 12, 13, 14, 15, 16 are missing because their MPG values are not greater than 15. Cool. So you can access the columns and create a new list using the condition that you want, so that you have data to process. This is a similar thing to your, wait, let's take a look at another example. Suppose I would want to just create two columns here. In my visualization, it only matters to me that I have the name of the car and I have the MPG value of the car. You do it this way. So you invoke my file, and then just say the names of the columns you want to include in your output. So name and MPG, I hit the enter key. I have the names of the cars, the MPG of the cars. And since we have an XY format where I have maybe the names at the x-axis, maybe the MPG values going vertical, I can now have bars for the values. And to do it, we can now proceed with importing Seabourn. Seabourn is a library that allows you to do visualization. Sorry, not to be confused with pandas. Pandas allow you to be able to tweak your data so that you are able to isolate the parts you want to visualize. When you're actually visualizing, that's when you need Seabourn. So let's try to use Seabourn by importing it. Import Seabourn as SNS. SNS is the nickname, so that we can use Seabourn by invoking SNS. we can use this SNS.setStyle white grid. The styles are in the documentation, which I will forward to you. Essentially, it's the same as the Google Docs, where there's a documentation we follow to determine what attributes we can tweak. Seabourn has that, Pandas has that, and I will be forwarding both of those things or all of these um, guidebooks to you so that you can tinker around with what to tweak depending on how you would want your graph to look like. All right. And then here, let's just use my file. Let's copy this one so that it is, sorry, I hit Shift Enter by mistake. Okay. So our output, we invoke SNS. SNS is Seabourn, right? Seabourn, we set its style. Now we're trying to tell it, Seabourn, please create a bar plot for us, where the x-axis would contain the names of my cars, and where the y-axis would contain the MPG values of the cars. And our data, the data, is precisely this. Yung na-generate na natin, the one that we generated. Let's just copy this one, place it here. Let's check if it runs. Shift Enter. There you go. What a beautiful graph. Let's try to zoom in again. So now, I know that those things here, the things at the bottom are the names of the cars that are mushed together because they don't have enough space to be represented. But these are the MPG values. I know just by looking at the graph that I have 3 cars whose MPG values are at least 30 or above, right? So it's speed. It's very speedy. Now, if you give me this graph, hi Nate, this is the graph of each car and their MPG values. Oh, so we have 3 cars that have MPG values of greater than 30? Great, I want that, right? It's very speedy, and that's the goal of data visualization. Cool. What else do I want to say? I want to say that this mushed up, I chose to end here, so it's less than 30 minutes. Great. I choose to end here because the tweaking of the names, we want it so that there's space for the names, because how would I know the name of the car if they are mushed? But this is left as an exercise so that you can, just like the Google Docs example, you can take a look at the documentation and see what attributes you can tweak in order to fix this. But this code I will already upload in our group so that you don't have to redo the wheel. Hopefully, this introduction is enough for you to be able to understand the reference exercise uploaded by your Sir Gabo. Visualization. So this is now, I will leave you with this. Try to please understand or just get familiar with what it does. You will, what do I suggest you do? I would suggest that you just understand how the component connects to each other, how the processes connect to each other. Because as you have seen from what we did, you do something in order for you to produce data that is in the format expected by the next thing that you will do. So just be familiar with those, with the flow of that, because that is what commonly happens when you're doing visualization. At this point, I will end the video. If you would have questions that the documentation might not be able to answer you, then send it to the group or send it to me, and I will try to answer for you. There's one last thing that I wanted to do, and it should be in the form of a question. Right. So, bit.ly CS tracker. We mentioned speed. Can you try telling me who among these students, so this is a grade book by context, try telling me who is the student who is doing the best in this class. Also tell me who is the student who is doing poorly. Sorry, this is unfair. I will send you the link to this public datasheet, and you tell me who's the best performing student and who's the least performing student. All right? Thank you. Thank you.